Welcome to the University of Idaho, Utah State University, and South Dakota State University Sheep and Goat webinar series. Today, our speakers come from the University of Nevada, Reno. Our next presentation is using GPS tracking to inform livestock management and genetic improvement in extensive systems. And our presenter is Dr. Andrew Hess. He is an assistant professor of animal genomics in the Department of Agriculture, Veterinary and Rangeland Sciences at the University of Nevada, Reno. His research focuses on how precision livestock farming tools, such as GPS tracking, can be used to support both management decisions and genetic improvement in remote and extensive production systems by integrating spatial movement data with genomic analysis. His work aims to develop scalable strategies for monitoring animal behavior, improving resilience, and optimizing grazing efficiency in rangeland environments. So I'm very excited to hear about this, Dr. Hess. So I will let you go ahead and get started.
Great. Thanks for that wonderful introduction, and thanks for the opportunity to speak at this webinar today. So just going to start off with a little bit of background. You all should be familiar with this, but just to kind of ease into this, we know that the human population, will continue to grow and is estimated to reach about 10 billion people before the year 2060. Along with this, we see increases in the global surface temperature due to climate change, which will shift what areas are considered arid and semi-arid due to changes in where rainfall and drought is going to occur. Along with this, we have some societal challenges, including the increase in demands for sustainable products. That increase in human population growth will result in less space for production, and expectations of an increase in animal welfare standards. This is coupled with those environmental challenges such as heat and drought stress, the spread of disease, including diseases in areas that they've never been seen before, as well as other animal health challenges. And so we really need to breed animals that can maintain a high level of production across a range of environmental challenges. This is a production efficiency problem. And one of the ways that we can accomplish this, and Tracy provided a nice introduction to this, is through precision livestock farming tools, which offer a lot of potential in terms of enabling novel trait development. For example, you can use GPS collars to track animal movement behavior, smart feeds for feed intake, green feeds for greenhouse gas emissions, smart scales for weights, and temperature sensors for body temperatures, and wearable sensors that have been developed to look at the welfare and well-being of animals. Most of the technologies that are on this slide are very well developed for intensive production systems, but less developed for extensive production systems, particularly ones in mountainous regions. And the reason why I think this is important is really because extensive rangeland production systems are a good testing bed for capturing measurements of resilience and efficacy or efficiency, excuse me, to multitude of challenges the animals.
Dr. Hess, I can't hear you very well. Yeah, I don't know if it's me. It sounds like it might be everybody. Do you have a microphone or?
Yeah, I'll try putting in my headphones real quick and see if that
Okay.
works. Is that better?
Yes, that is better. Great.
Cool. All right, so where was I? So the reason why extensive production systems are ideal for capturing these measurements of resilience and efficiency is because of the number of challenges an animal faces. For example, they are exposed to extreme temperatures, such as extreme hot and cold. They have limited resources in terms of food and water. They have to traverse varied terrain in order to gain adequate nutrition to perform, and they're at risk of predation. However, on the side of the technologies, there are similar challenges for many of these precision livestock farming tools, including extreme weather, which can impact the functionality of these tools, limited access to power and internet. A lot of these precision tools do rely on Wi-Fi or things to transmit the data. And so being in remote regions of the world has certain drawbacks there. In addition to difficult terrain, which encumbers the ability to get the equipment to the areas where they'll be most useful, and our ability to track animals is limited in these wide open spaces. And so we're thinking about different precision livestock farming tools and what they could mean in terms of being useful in these remote environments. And one of the technologies that we approached first was GPS collars. The first collars that we used were designed at University of Idaho by Jason Curl. And we can see it here on the right-hand side. There's a unit and a battery. And on the left is a housing, just some PVC pipe used to protect the instrument from dust and rain and other elements. And so using these collars, we deployed them on 112 sheep, including ewes and lambs, and most of these were actually paired. And we started to think about what sort of phenotypes or characteristics might be useful for an individual. Some of the things that make sense that come naturally out of a GPS unit is location data that's can be seen in plot A and figure A. We can actually see what areas the animals are using the most. In the middle of this sort of figure 8 pattern that's on this panel A, we see a focal point right in the middle, and that's where the night pin is for the study. So we're able to see what areas are hit the hardest or grazed most intensely during turnout. We can also get distance traveled for an individual and identify patterns. And what we can see here is that the sheep tended to move in a figure eight sort of pattern, going north in the morning, coming back to the night pen, which is where the watering hole is during the midday, and then going south in the evening. And in this animation on the left-hand side, we picked out two individuals that are extreme for daily distance traveled. And we can see that the red individual tends to take a longer path than the individual in cyan. And so we can utilize this information and the fact that we're able to collect multiple records, not only within a day, but across days, to look at consistent behaviors, or how consistent these behaviors are within an individual, which is how we can get a first pass estimate of how heritable these traits might be. In addition to just what comes off the GPS collar natively, we can integrate this with other types of data, such as NDVI. So Tracy mentioned this in her talk, which is a measurement of vegetative richness. And rather than being a feature of just the cell itself, what we're doing here is we're actually treating that as a feature of the animal. So how the animal on average tends to behave in these little plots, and how so we can use features, terrain features as a characteristic of the animal. We can do this not only for NDVI usage, but also slope and elevation. And one thing that we were thinking of is when scaled relative to the rest of the flock, this can be an indicator for selectivity. It's basically a measurement of how much in excess or in deficiency relative to the flock the animal is in terms of occupying spaces that are more vegetatively rich, which we're doing the work now to look at whether that has an impact on, or whether that can be an indicator of the nutrition of the animal. In addition, we can look at things like social relationships, for example, gregariousness, which we defined as the distance of an animal on average from the center of the flock. And so we've got a plot here on the left where the bar represents an animal, and bars pointing towards the center of the circle are more central to the flock. They're found in the middle more frequently, whereas animals that are on the fringe here are more distant from the center of the flock on average. In addition, we can look at things like ewe-lamb relationships, and and quantify or use GPS measurements as a way to quantify mothering ability. So we were interested in how repeatable these traits are across days. And what we found was for things like daily distance traveled, gregariousness, elevation usage, slope usage, and NDVI usage, that um, there was a very large day effect, which isn't too surprising. There's a lot of day-to-day variability and management. But if you then scale these relative to the flock, you get a much more repeatable measurement across time, and the day effect shrinks down to zero. Interestingly, we did this in both ewes and lambs, and we found that the repeatability or the consistency in behavior for ewes, which was much higher than lambs. And I think this makes sense because there's more behavioral plasticity and whatnot in younger animals. If for any of those of you that have kids, you know how unpredictable they can be at times. And so the that was kind of the pilot study, if you will, for testing out these GPS units. One thing that we noticed when we were actually going through and doing this was that the units for the housing with the housing was they were heavy, about half a kilo, and so not really ideal for putting on young lambs. Activating them was also cumbersome, so each unit needed to be activated by hand on site, and um, the exposed parts meant that sometimes things shook loose and resulted in no data capture. So this variability led us to explore other options, and we settled on I got you units, which are commercially available units that are low cost. And the reason why we liked these was because they had a much longer battery life. They were Bluetooth enabled, which made it easier to pull the data off of the units. And they were also sealed, making them water resistant, allowing us to reduce the weight of the collar itself. In addition, these were programmable, whereby you could set an activation date and set time periods per day where they were active. And you could modulate the sampling frequency. The unit itself was also much lighter, weighing in at about 21 grams. And so we felt more confident putting these on younger animals. So we did a test to actually compare the completeness and runtime of the old and the new units, and we found that the newer units were much more complete, with most of the data points actually collecting meaningful data, and they ran more consistently and longer than the old units. So we conducted another trial using about 200 units in a follow-up study, and we found that And in addition to this, we tested out some algorithms for actually filling in the data and looking at behavioral states. And so we used a program called Momentum, which is described in this paper here, that allows us to regularize the time points and fill in missing data. And in addition to that, we can derive predicted states, so active versus resting, in these animals. And so this led us to explore whether the repeatabilities of these different traits may differ between the active and resting state. And we found that certain traits did have different repeatabilities, whether they were in the active or resting state. For example, daily distance traveled, while having a pretty good repeatability in the active and resting state, was more repeatable in the resting state. And the interesting thing here is that these are actually slightly negatively correlated, which means that we are describing different attributes of the animals, whether they're in the resting or active state, which may play an important role when considering their associations with other production traits. So just a few slides to sum things up. We'll need to develop novel phenotypes that need to be captured in previously untapped territories. If we want to generate enough data, we need to focus on low cost and high throughput phenotyping without impacting data quality. And really, GPS collars are a good way to approach this, because you can capture a number of different characteristics on the animal, ranging from individual animal phenotypes to social networks and land utilization. And the integration of these will provide with other data types, will provide a more holistic view of what makes an animal more resilient and efficient in these challenging landscapes. So just to think about how kind of this can be used in a management or selection context. In terms of management, we can use this to adjust our shade access and supplement placement, look at our flock composition and remove problematic animals, such as those that are chronic wanderers. And we can match the timing of grazing rotations to match landscape use tendencies. Thinking about the Bluetooth capabilities and the newer units, this may provide the potential for real-time or near real-time alert-based monitoring to identify animals that may not be as efficient or may be injured and have health or welfare issues. On the selection side, we can use repeatable traits to flag animals with undesirable profiles, combine GPS, environmental, and other data sources to uncover new metrics, and estimate heritability to drive trait improvement, ideally integrating this with NSIP or flock selection, or using flock selection indices. So what are some of the other things that we might be able to integrate this with? We've looked at vaginal temperature sensors. a portable weighing system to get longitudinal weights, fecal samples to capture what they're eating, get health and nutrition and from the perspective of minerals, cortisol to look at stress as well as methylation patterns. We can develop what's called an epigenetic clock, which estimates the biological age of an individual. And if that biological age exceeds the chronological age, it may be an indicator that the individual is not coping well with stress. And with that, those are some of the things that we've been working on, and thanks to all of these people that have helped data collection ideas and other and whatnot, especially thanks to my former student, John Bergeron, who did the bulk of this work. And with that, I'll take any questions.
Yeah, I don't see any questions popping up just yet. We'll give it a couple minutes and see what people might have. Tracy, you can go ahead and talk if you need to. I see your hand is raised.
Okay, I'll just ask the question, Dr. Hess. If someone was a smaller sheep producer, what kind of precision livestock farming do you think small producers are going to engage in first?
That's a good question, and it really depends on the production system that they're in. Like I said towards the beginning of my talk, there are a lot of tools that are really well established for intensive production systems. They're designed to be in close quarters and things like that. So an operation like that might look at things like smart feeds to improve feed efficiency. Obviously, I'm a little bit biased towards GPS collars because I think that they can actually provide you with a lot of information about the behavior of the animals that can translate across those different production systems. And so I think that these tools are a really valuable data mining resource to be able to pull a lot of information out on the individual as well as the flock as a whole, and adjust your management practices based on that. And so the cost of these technologies keep going down. And so for a small scale production system, I would recommend going for the things that are cheaper, more affordable, and then as the tools continue to develop and reduce in costs, kind of go from there.
So we did have a question come in. They asked about the use for preventing predation and if you've tried putting the collars on like the livestock guardian dogs for tracking.
Yeah, so we were interested in, I haven't quite looked at this because our trapper does a pretty good job out in our allotment, but one of the things that we are interested in is to identify areas where predation might be a bigger issue. And so we can use things like changes in and the direction, sharp changes in the direction and speed to identify problem areas where there might be a predator. And use that to inform our management decisions. What was the other question?
If you put the collar on any livestock guardian dogs?
We haven't yet. That's a good idea. It's something that we talked about at one point, but we haven't done that yet. But that's a good idea.
Yeah, that'd be really interesting to see what they're doing and traveling along as well. So. Okay, well, we have met our 1 hour limit and I don't see any other questions coming in, but I'm sure people can find either of you and send you an email if they have further questions. And you can always comment on our YouTube or the Facebook and we can pass those along to Andrew and Tracy as well. So thank you both for being on with us today.